Everyone, I want to do some of the problems out of your quest homework for you. The first one I want to do with you is number 27 with the lifeguards pulling on a rope on a raft, and they're pulling in two different directions. In the first scenario, both lifeguards are pulling in the same direction, and the total force that that raft feels is 375 newtons to the right. However, in scenario 2, they're pulling in opposite directions now, and the net force ends up being 109 newtons to the left. Now, which force you call 1 and 2 is completely arbitrary and up to you, but we know what those forces are resulting in. The question is, what are those two forces? What is force 1 and what is force 2? So if I look at the first scenario, that's pretty easy. Force 1 plus force 2 has to be 375 newtons. I don't know which they are individually, but I know what they combine to. In the second one, they're going to pull in opposite directions, so I'm going to make force 1 negative, force 2 positive, and I know that the total force is a negative 109 newtons left. I don't know force 1 or force 2, but what you can do is solve for one of them. I'm going to solve for force 2 in this case, and plug it into our other equation. So just rearranging our formula here and getting some algebra, I'm going to take force 2 equation, put it up above, and I'm going to write one big force equation from above. Force 1 minus 109 plus force 1 will equal 375. Rearranging this again, I have two force 1s there, so force 1 plus force 1 is two force 1s, and moving the 109 to that side gives me 484. Solving for force 1 by getting rid of that 2 gives me around 242 newtons. Now, if that's not the answer they want, maybe they're asking about the other lifeguard. And when you do that, you get around 133 newtons on mine. Remember that your problems will have different numbers, so good luck. The second problem I want to do with you is 53 and 54. It's a two-parter about an airplane flying in a horizontal circle. We're not doing vertical like we did last time, just horizontal. So really, the friction between the pilot's butt and the seat are what's going to keep the pilot in towards the center of the circle. They give you some information about speeds, they give you the mass of the pilot, but the first thing they're saying is what radius can you go around and maintain an acceleration of 6 times what gravity does, 6 times that free fall acceleration. So here's my drawing of our scenario. Remember, objects in circles want to go in straight lines, and this object's trying to fly away at 100 meters per second. The mass of the object is given as 71, and the acceleration is 6.61 Gs. Going beyond that, it's going to make that pilot pass out, and we don't want that to happen. So the question here was, again, the radius. And since we know the acceleration around a circle is just the v squared over r part of my force equation, I know the velocity, I know the acceleration can't be beyond 6.61 Gs, so rearranging, I'm going to do v squared over my acceleration. So when I put everything in and I crunch out my numbers, I get my radius of around 154.22 meters. So now I know the radius of my circle. 54, the part 2 of this, wants you to find the force needed to maintain that circle. So I'm just going to draw the pilot as a box here and draw the forces that are acting on him. Gravity is obviously pulling him down. The seat's going to push back up and support. And again, the pilot wants to go forward and fly level, so there's got to be a frictional force from his seat pulling him in towards the center of the circle. There's an unbalance. That centripetal force is going to end up being our frictional force. And we know how to calculate centripetal by doing mv squared over r. So putting in all our variables again, mass, velocity, squared, don't forget to square, and our newly found radius from part A, we can crunch out all our numbers here and end up with 4,603 newtons of force, 0.9 newtons of force. That's the amount of force that your seat has to pull to maintain your circular motion. If not, your body's going to go in a straight line and fly out of that circle. So good luck.